Alright folks, this is our last example for lesson 2. So if you would turn to page 9 please, and you'll find example 3, finding sums on a real number line model. Okay. So we call them real numbers because they're not imaginary numbers. Those are things you're going to talk about in some of the top classes that you'll take in math when you are in high school. So just know that we are talking about real numbers, not imaginary ones. Okay. You will see that I color-coded my vectors. Remember, those are those arrows on my number line. I tend to color-code a lot of things. Green for positive, this reddish pinkish color for negative numbers. For those of you who are visual thinkers, visual learners, I know that that can be pretty helpful. I am one myself. You don't have to color-code them, but it's totally okay if you do. Right? What we are going to do now, instead of starting with numbers and drawing a diagram, is this time we are going to start with a diagram and try and figure out what it's telling us. Alright, so we have this diagram. We have a vector 5 spaces along to the right, and then 2 spaces to the left, and then 3 spaces to the right. And from there we need to write an equation to express the sum. But if you look at this, we don't really know where it ends because they forgot one step. They forgot to circle that final number. Okay? So we're going to go ahead and circle the number 6 to show that that is where our last vector or arrow ends, and therefore we know we're done with the problem. Okay? And then when we go to build our equation, we always want to start with a number that is as closest to the number line as possible. So in this example here, our first number in our equation is going to be the number 5 because it's closest to the number line. We're then adding on or counting on a negative 2, the next one up, and then our final number is positive 3 because it's the one that's furthest away from that number line. Okay, so we have that again, positive 5, the negative 2, the positive 3, and when we add all of those together, it equals 6. And you'll see that my numbers are color-coded similar to my vectors. Okay. Again, with that integer game, we want to know what 3 cards are shown in this diagram here. Well, the cards are simply the numbers that we're talking about, the 5, the negative 2, and the 3. We can know that either by the numbers that are drawn on top of the vectors, or by determining the absolute value or that distance, the length of the arrows, and then what direction they are pointing. In lesson number 1, we had a model where we were looking at integer cards, or integer game cards, and we then had to try and figure out the sum. This one is a little bit different because we have 3 numbers instead of 4. We have arrows, or those vectors, remember that's that key fancy vocab term, instead of the little hoppy loopy things that are jumps. And in lesson 1, we had the numbers 5 and negative 5, and they canceled each other out. We got back to 0 because they were opposites. This time around, we don't have any opposites. Okay. We're going to zoom past letter D and go to letter E. And this one is asking us, would the sum change if we change the order in which we add the numbers? So instead of 5 plus negative 2 plus 3, what if we had negative 2 plus 3 plus 5? So same numbers, different order. Okay. Again, as we've already talked about earlier in this lesson, hopefully you remember that no, that order isn't going to matter. The sum would stay the same. Because we are adding, we can add them in whatever order we want. Again, that's that commutative property of addition. Okay? However, the diagram would change. So letter F is asking us, would the diagram change? And if so, how? And yes, it would. Because when we write an equation from a diagram, or if we go to diagram an equation, the first number is always the one closest to the number line. Okay, so now this time, our first number is negative 2, so that is now going to be the closest number. Let me move this out of your way here. That would be then the arrow closest to that number line. And because we would then end with the number 5, that's going to be the arrow or the vector furthest away from the number line. All right? So why do we draw those arrows, those vectors, instead of all those smaller hops? It's just easier. It's easier for us to see. It's less work, in all honesty. Sometimes our loops tend to get a little bit sloppy, especially if we have to bring them up above the line. So we are going to be using the arrows and not the little bumpy loops. And what we did today is figured out how we can use a number line to help us add some numbers. Okay, so I know that adding positives and negatives, for some of you, you came in knowing this. For others of you, not so much. But we are going to be relying on that number line to help us as much as we need to. Okay, so don't be afraid of that. All right. There is one more question on that Google form for you to answer. And then this concludes the notes portion of lesson 2.